right, let's look at another example here. To determine the sample size n that will yield a certain confidence interval for the population proportion. So basically, if we want a desired margin of error, so on this previous problem, we had a margin of error of 3%. Well, what if your boss says, I want a margin of error of no more than 1%? Or you know what, on this problem, a margin of error of 10% is okay. So how large of a sample would we need to get that desired margin of error? Okay. So the margin of error, remember, is everything behind the star. So we've been looking at categorical data or one sample or one proportion z intervals. So p hat plus or minus z star times the square root of p hat times 1 minus p hat all over n. This chunk here is the margin of error. So if they tell us what margin of error that we want, we can calculate how big of a sample we would need to do that. Okay. The smaller the margin of error, the larger the sample is going to be. Sampling is very expensive, very time consuming. So if we can minimize the size of our sample, we can probably save ourselves or our customers or our company lots of money. Since we do not know what p hat is. P hat, we don't know the true population proportion. So we are always, in solving for n, given a desired margin of error, we're always going to use 0.5. No matter what, we use 0.5. That way it gives us the largest n. So if p was smaller or larger than 0.5, we would still be safe with this size of a sample to meet the required parameters that were put onto us. So let's do some calculations with this. Let's look at an example. A company received complaints about its customer service. The managers intend to hire a consultant to carry out a survey. Before contacting the consultant, the company president wants some idea of the sample size she will be required to pay for. One value of interest is the proportion P of customers who are satisfied with the company's service. She decides she wants the estimate to be within 3 percentage points or 0.03 of the 95% confidence level. How large of a sample is she going to have to pay for to make sure that her estimate is within 3 percentage points? So the margin of error is equal to z star times the square root of p hat times 1 minus p hat over n. Well, we want a margin of error of 3%. And we want to be 95% confident. So 95% confident, when I look at my handy dandy table B, 95% confident z-score, that's 1.96. So 1.96 times the square root. I don't know what p hat is. So I always use 0.5. My job is to solve for n. So I need to solve this equation for n. Now we're going to do some basic algebra. Okay? So the first step is let's divide both sides by 1.96. I'm trying to get n by itself. So I have 0.03 over 1.96 equals the square root of 0.5 times 0.5 divided by n. Now I need to get rid of this square root. So the inverse operation of square rooting something is squaring it. So now I have 0.25 divided by n is equal to 0.03 divided by 1.96 squared. Well, I'm getting close. So now I need to get n all by itself. And remember, I want a margin of error of less than or equal to. So I should be consistent here in putting those there. Less than or equal to 0.03. So if I multiply both sides of this equation by n, that will make these cancel out. Okay. So now I have n times 0.03 divided by 1.96 quantity squared is less than or equal to 0.25. But I want n by itself, so I'm going to divide both sides by 0.03 over 1.96 quantity squared. So I'm going to see that N has to be N is going to have to be greater than or equal to sorry guys. So N is going to have to be greater than or equal to 0.0 or 0.25 divided by 0.03 over 1.96 squared. So N is going to have to be greater than or equal to 1067.11. But I can't sample 0.1 of a person. So always when solving for N, given a desired margin of error, we always round our answer up. So N must be at least 1,068 people to satisfy your boss's requirements. Okay. I know this is a lot of work, but once you get the process, it's going to be pretty easy. And I try to do it all by hand, not using a calculator. So when you're using your muscle or your calculator, it's going to make things a lot easier for you. Okay, so if we know the desired margin of error and the confidence level, we can then tell or determine or tell somebody, hey, you better take a sample of this size to meet these requirements. So that's what this was all about.